Hello students, I am Shlok Kulkarni. I welcome you all to my YouTube channel, and today we are going to continue with our chapter 9 Altimetry from Oxford Meteorology back questions. Now we are going to do from question number 10 to question number 14. So these 5 questions we are going to do now. So let's start. So question 10, first question. Hello students, I am Shlok Kulkarni. I am back with my YouTube channel. Hello students, I am Shlok Kulkarni. I welcome you all to my YouTube channel. We are going to continue with our Chapter 9 Ultimately Solved questions which are from Oxford Meteorology. These questions can be found at the back of this Chapter 9 Ultimately chapter. These questions are very important for your DGCA exam as well as for flying or any other exam that you are taking. So the understanding of the concept and the confidence in solving the sums is very important. Now we are going to do questions, 5 questions. Question 10 to question number 14. So let's start with question number 10. The first question of the day. How do you calculate the lowest usable flight level? So the lowest usable flight level basically means transition level. Now we have the airport over here. Let's say we have an airport. We have a transition altitude. Okay. We have a transition layer. And then we have transition level or the lowest usable flight level. The first flight level. Now at and below transition altitude, we set QNH in our altimeter setting window. We set QNH in our altimeter setting window. At and above transition altitude, we change our altimeter setting from QNH, okay, from QNH to standard pressure setting when we are climbing, when our aircraft is climbing. When our aircraft is climbing. Okay. So when we are climbing across beyond the transition altitude, we will cross transition altitude. So that time we will change our altimeter setting from QNH to standard pressure setting. Now when we are descending from above the transition level to lower levels, that is when we descend below transition level, it is a duty to change our standard pressure setting to QNH setting. Standard pressure setting to QNH setting. So when climbing, QNH is changed to standard. When descending in the transition layer, we convert standard pressure setting to QNH pressure setting. So this is the procedure that we follow. Now the lowest usable flight level, which is a transition level, is governed by two factors, or the authorities decide this transition level or the lowest usable flight level depending on two factors. These are colder than ISA conditions and lower pressure, lower than standard atmospheric pressure. Okay. So these two conditions we studied in the barometric pressure and barometric or pressure error and temperature errors of altimeter. The video of that in which I have explained this concept in detail You will find that video in the knowledge series playlist. And in that we saw these two conditions of atmosphere will give you true altitude lower than indicated altitude or true altitude less than indicated altitude. And flying in these two conditions is unsafe because the separation or clearance between your aircraft and the obstacle below you decreases or reduces, and therefore flying in these two atmospheric conditions is unsafe. Okay, it's regarded as very unsafe. In fact, we also say when you fly from high pressure region to low pressure region, watch out below. Means look outside your aircraft or look outside the window of your aircraft and check whether you are at a safe distance from any obstacle below you. So this is the threat associated with these two atmospheric conditions. And when these two atmospheric conditions grow in value or become very intense, for example, if colder than ISA conditions, the temperature becomes more and more colder, the error due to this temperature will become more and more, and therefore it will be more unsafe. Okay, it will become more and more unsafe to fly in such a colder air mass. Similarly, with a pressure which is lower than standard atmospheric pressure, if this low pressure deteriorates in value or decreases in value very fast, okay, so more the low pressure becomes intense, more the pressure error will be, and more the true altitude will be less than the indicated altitude. So these two conditions make it very unsafe to fly in such atmospheric conditions, right? So when we are flying at next point, when we are flying at lower levels, we use QNH. But when we go to higher levels, this QNH pressure setting or local atmospheric pressure setting become very unreliable. So when we fly at high altitudes, we switch to standard pressure setting, which is used by all aircraft over the globe. So this gives you uniformity. This relieves you from the task of resetting your altimeter setting window to local atmosphere setting from time to time, because local atmospheric setting will change from place to place during the course of your journey. So if you forget to reset your altimeter, you are instantly subject to pressure error and temperature error. But when you fly on standard pressure setting, irrespective of local atmospheric setting, you are free from these errors, and you are relieved from the duty of resetting your altimeter from time to time. The only duty that is in your hand, that is on your hand, is that when you cross transition altitude during climbing, you change from QNH to standard. When you descend, you change from standard to QNH. Now coming back to the question, the first flight level, as I said, will be governed by colder than ISA conditions and low pressure. Okay, so more intense they are, it is better to switch to standard pressure setting, because in such cases, uh, operating on QNH, a local atmospheric setting, will expose you to unsafe conditions where your true altitude is less than indicated altitude. So option number A is the correct option. Lowest QNS means they are talking about lowest pressure possible in that area. Lowest negative temperature means they are talking about temperature, colder and colder temperature. So these two conditions we should stay away from. Okay. Let's go to question number 11. So of all the four options, option number 1 is the correct option. Question number 2 or question number 11. QNH is 1003. Flight level is 100, and still your true altitude is 10,000 feet. So this example, let's draw. So this is QNH 1003 pressure level, and now flight level 100. Whenever we talk about flight level, we should talk about 1013 pressure level. So standard pressure setting 1013. Okay, so this is visible to you. Now flight level 100. Let's draw flight level 100. Now, when you are talking about flight level 100, that vertical distance will be measured from reference datum standard pressure setting 1013. Okay, whenever you are talking about flight level, the reference datum will be 1013. Now, whenever you're talking about altitude, the reference datum will be QNH. Okay. So, this is your altitude, this is your flight level or pressure altitude. Now, as you can see in the picture, definitely flight level is more than altitude. Okay, looking at the diagram, you can see that flight level vertical distance is more than altitude. So basically, if you're flying at flight level 100, which is 10,000 feet, your altitude should be less than 10,000 feet because you are measuring that altitude from QNH level, and therefore it is less than the flight level. Because out of the total flight level of 10,000, we are subtracting this much height from the 10,000, from the entire 10,000 feet. When we subtract this much height, we will get altitude, and therefore flying at flight level 100, your altitude will be somewhat less than 10,000 feet. Okay, just looking at the diagram you can see. But the question says your altitude is 10,000 feet. That means that altitude has not decreased, that means that altitude has increased. So what atmospheric conditions will increase your true altitude? So there are two atmospheric conditions which will increase your true altitude. First is warmer than ISA conditions, right? And second is high pressure air mass. These two conditions tend to increase your true altitude more than your indicated altitude. So again, repeat. Step 1, looking at the diagram, just the diagram, your altitude, your true altitude should have been less than 10,000 feet. But the question states it is not less, but it is equal to 10,000. Means something in the atmosphere has helped or favored in the increment of true altitude. So that can be either warmer air mass or high pressure air mass. So let's check the options, what options we have. Warmer than ISA, yes, probably. Colder than ISA, no. Colder conditions tend to decrease your true altitude. Same as ISA, that can be that can be one case that I will talk about, and cannot tell. Okay, so delta is also eliminated. Bravo is eliminated. Now see, when flight level, okay, the level you are flying, the indicated, when indicated altitude, that is the level you are flying, which is 10,000 feet. If indicated altitude is equal to your true altitude, that means we can say we are at ISA conditions. Okay, we are at ISA conditions. Correct? And ISA conditions. But looking at the QNH, which is 1003 given to us. Okay, QNH is 1003. So in ISA at 10,000 feet, okay, whatever pressure is there, we are not concerned about that because we are flying with standard pressure setting 1013. But when we measure our altitude from 1003, definitely less than flight level. Okay, so when we keep that in mind, the correct, more appropriate option will be warmer than ISA condition. Okay, we cannot say that we have ISA conditions in this particular air mass because we don't have further information or extra information like whether the flight level at which we are flying has the same atmosphere pressure value which should be existing at ISA. Okay, we don't have additional information, so it won't be proper to say that we are currently flying in ISA conditions. So although this option looks possible option, the correct will be warmer than ISA conditions, calculating from QNH. Okay, why not ISA conditions? Because we don't have more information, so more appropriate will be to option A. Otherwise, when indicated is equal to true, that happens only in ISA conditions. But we are not selecting that options because we don't have more information to base our conclusion on. Let's go to question number 12. How is QNH determined from QFE? Where many times we have solved this question. If this is your airport, at airport you have QFE and this is your QNH. Airport elevation above mean sea level. Okay. So the factor which joins QFE and QNH is elevation. So if QFE is given, elevation is given, using those two values you can calculate QNH. If QNH is given and elevation is given, using them you can calculate QFE. If elevation is not given, but two pressure values are given, using them again you can find elevation. Okay, so this is the factor which joins QFE and QNH, and therefore the correct option will be Charlie. Using the elevation you can determine QNH from QFE. Question 13. You are flying from A to B at 1500 feet. Which statement is correct? Okay. Now look at the isobars at location A. The isobars are close together. That means we have steep pressure gradient, and isobars here are far away from each other. So the pressure gradient there is weak or slack. Next point. Now how to determine what is the pressure at location A, what atmospheric pressure is at location number B. So now here they have given the wind which is coming from the northeast. Melbourne is in the southern hemisphere. That means by that conclusion we have north here, east direction here, south here and west here. Now this wind is coming like this. So somewhere from northeast. Now, when winds blow in the northern hemisphere, according to Ballard's law, we will have low pressure, okay, to the left hand side of the wind. So that means we have low pressure at location A. Okay, we have low pressure at location A. And according to Ballard's law, high pressure will be to the right hand side. So somewhere over here we have high pressure. Somewhere over here we have low pressure. Okay, so if this is low pressure, right? So comparatively, these isobars are far away from each other, means pressure over there is more than low. So we can say if we are going away from low, any pressure will be high. Okay. Now we are flying from A to B, means we are flying away from the low pressure region. Okay. Now over here there can be high pressure or there can be pressure which is low but not as low as this low pressure. So we can regard that pressure region as high. Okay. Now when we are flying from A to B, meaning we are flying from low to high pressure or we are flying away from this intense low pressure. So when you go towards higher pressure region, comparatively your true altitude is more than your indicated altitude. Okay. So what will be the option correct? True altitude at B. B is high pressure, higher pressure compared to location A. So true altitude that side will be more than altitude at A. Question number 14, last question. QFE 1000, elevation 200-meter above mean sea level. So just now we saw how is QNH determined from QFE. Now that is the practical example of that question. 200 meters, pay attention. So QNH is what? So 1 hectopascal is 8 millibar, 8 meter. So 200 meter will give a pressure difference of 8 2s are 16, 8 5s are 40. So 25 millibar. So QNH will be more than QFE because it is below QFE. So 1025 hectopascal. Simple. This is the pressure difference and you add that pressure difference to QFE. So 14 is Bravo. So with this we come to an end to today's lecture. Today's lecture we have solved 5 questions, easy 5 questions. Solve them, watch this video carefully twice. Solve them with the help like how I have done and then close the video after some time. Do these questions on your own. See how much you can do them on your own. That will give you more and more confidence. So all the best. If you have liked this video, hit the like button. Let me know. If you have not subscribed to this channel, subscribe to this channel. so that you keep getting new notifications and reminders on time. And do share this video with everyone so that everyone gets the benefit. Thank you for your time. Keep learning. All the best.